Hey guys, in this video I'm going to be going over my latest project for multiplayer. I've restarted these sorts of projects quite a few times, and the main reason for it is that every time I start a project, I get to the end of it having learned quite a lot, and it's also the fact that I'm working generally quite fast to the point where I learn new programming techniques and styles, patterns, and actual functional Python. Over the space of the project, so by the end of it I'll be a better programmer than at the start quite significantly. And sometimes these changes are so big, and also I come across different techniques that I have to start again with my new found techniques, because the problem with writing code is that it gets to the point where you become attached to what you've written, and I find it very hard to let go of what I've written, even if I I'm constantly considering the fact that something isn't right, but I don't want to get rid of it because I don't want to mangle the entire system, and it's sometimes really hard to maintain scope. With my current project I'm working on, it's been tricky to maintain a sense of openness, and my gut feeling is sometimes that things aren't right. But I'm starting to believe that perhaps this is just my own issue with how I'm treating the entire system, because in a lot of ways network programming is completely contrary to what what programming really should be, because in Python you don't have static types, whereas in multiplayer and on networking you have to know how you're sending your data, because you can't unpack it arbitrarily. You pack integers in different ways to pack strings and so on. So it's a little bit tricky to manage, but hopefully it'll be alright at the end of it. The other thing is as well that you have to get things fast, and it's about making sure you don't compromise the point in programming in Python, which is the beauty of it and the ease, with the fact that you need speed. So that sort of little lecture aside, what do I have? Well, at the moment, it functionally, in its core, it works, and it's very sort of simple but then very complex, in the sense that you have, at the moment it's only 400 lines of code, and it's going to be a bit bigger than that by the end of it. I'm trying to testing out an API to see how things work, but essentially we have a test file here, and the way you use this is you create your classes, and they have to inherit from the replicable base class. Anything that inherits from a replicable base class will have some special behavior defined. Firstly, whenever you instantiate an attribute, that attribute is treated as a descriptor, and it also allows you to specify specific arguments like notify, complain, and so on, so that they're intelligent. But also, we have the ability to, when an attribute is changed by the network, we can receive a callback through this notify function. We can determine when we want to send attributes by using a special conditions function. This is actually a generator. And also, there's some other stuff I haven't implemented, like net priority, and roles aren't being used at the moment, but they will be. I've also experimented with how to program the entire system, because I'm used to having everything modularized and working with instances, and so it can be very tricky to work out how you should inform a global system about a global variable, because I've always hated using global variables, because I've always worked in Blender, and Blender always requires the entry points, because you often share logic between different objects. You can't use global variables really. You have to, unless you explicitly want to. So I'm trying to get my head around that. It's weird. I just feel averse to using it. But anyway, that's the way it is. The other trick is that in the system, I'm sometimes caught between, should I explicitly state it to be a client, or should I have it naturally assume that role based on the conditions it's working with? But I tend to believe that I should tell it to be a client or a server explicitly, because let's say that those conditions that it works off were to change mid-program, a client would become a server and so on. That'd be very bad. Anyway, that's a lot of talking. What's going on? Well, firstly, you'll see at the very top I have all my network stuff. I have the Blender game engine stuff, well, math utils. I also import some game rules, and I also import the BGE types. And what all the BGE types does is it gives me some special, basically I register some specific Blender game engine logic for wrapping math utils types. I'm sort of trying to work on the approach that this could be used for any game engine, so it'll help me to maintain an open scope. And then later on I'll add the interfaces for Blender. Anyway, so then we define ourselves a robot, and it inherits from replicable. And that's fine, it gives you some random code, it doesn't actually do anything really, anything interesting anyway. And then what I do is I have this thing called channels, a list of channels, and the way in which the system works is quite easy to understand. So the best way to show you how this works, these two C's as such are clients, and if I can zoom in perhaps, and the S in the middle is the server, and then here are two actors. So actors are basically game objects, for want of a better word, but they're special game objects that can send their data across the network. They don't actually have to be physical objects, they could just be data, rather than manifesting themselves in meshes, but that abstraction at the moment might have to go. I don't know how feasible it will be. But anyway, that's not correct, sorry. I'm not sure how best to implement that, is what I mean to say. Not that it won't, it'll have to go. That distinction will have to exist. So anyway, clients interface with the server over something called a connection. And a connection is simply a way in which we can deal with an individual client and remote peers, because you might have 50 actors or 50 game objects in a game, but only, let's say, 10 of them are controlled by connected clients. That means that only 10 of them need to be told about where they are, because the rest exist on the server. So these connections allow us to isolate the replication logic for replicating variables over the network to only the client-controlled objects. Or in this case, clients don't have to control objects, they could also be a listening client. So simply for objects that need, they provide pathways to replicate data to the other end. There's also this thing called channels. Channels exist one for every actor, and you'll see in the red I've written number of channels equals number of actors by number of connections. One replication channel exists for every connection, for every object. So if there's 10 connections and 10 objects, that'll be 100 channels. This is basically because we can then move all the replication logic away from the game objects and onto these channels themselves, without having to house it on the connections. Simply because each object will have its own state of replication. The last variable is sent, but it might have sent its data to one client and not to the other, for various different reasons. Perhaps it didn't need to tell the client, or perhaps the client only disconnected. So we have to maintain a different state for each client, but also those variables belong to really an interface between the client and the so between the object and the connection itself. The connection shouldn't deal with replication. The connection should only deal with sending data. So I need to make sure I isolate that abstraction. And that's mainly the crux of the entire design. Variables can only be replicated in one direction, and that's to clients from servers. I did consider making it possible to do it in either direction, but this doesn't seem to be logical because it makes so many corner cases that it will be very difficult to pin down. And it's best to simply explicitly force the user to behave in one way rather than suggest it, but give them the option not to, because there will be inevitably someone who will make a mistake. So in order to send data upstream, you have to use something called function replication. And function replication is essentially invoking a function on a remote client. And that can happen from server to client or client to server. The only requirements for function replication is that when you replicate a function, when you invoke an RPC from one object, RPCs can only ever stem from actors, and they can only ever be invoked if either the object running the function or the one it's sending it to, the target. Let me rephrase. They can only be sent. They can only be executed. An RPC can only be executed on the other side if either the one person who sent it was the client who actually who this object represents on the server, or if it's in the other direction, if on the client the server sends the function call. So in other words, one of the two people who's in sending or receiving the RPC has to actually control the object. So the reason that server controller actors can be replicate functions to clients, even though none of the clients own them, is because the server owns them. So that's the way that works. That's the rules for that. And that's most of the replication rules. It's basically based off Unreal. I don't think I want to copy everything now. I'm trying to make sure I have my own model, because some of the things I don't agree with, and some of them are just very obfuscated. I'm worried that I'll spend too much time trying to get to the end rather than actually getting there. I'll do another video and carry on, I think.